Okay, so Jimmy's selling two tyres, superior and regular. So, all right, and depending on the quality, an inspector is used to classify them in order of manufacturer. So if a tyre is superior, then the probability the next supplier is superior is P. If a tyre is regular, the probability the next tyre completed is superior is P minus 0.2, that is. So on a particular day, Jimmy finds that the first tyre inspected is superior, and so then the probability that the third tyre is superior is 0.7. So we need to show that on this day, the p-value, so the p-value is equal to 0.75. So if we consider what a probability tree diagram would look like for this, we have superior and regular tyres, and if we've got a superior, the probability of the next tyre being superior is P, which means the chance of the next tyre being regular is 1 minus P. All right. I.e., if P was 0.3, 0.3 superior, 0.7 not superior. If my tyre is R, it says the probability of the next tyre being superior is P minus 0.2. So then the next tyre being regular is 1 minus P minus 0.2. So if we distribute that negative sign through, you get 1 minus P plus 0.2, which will give me 1.2 minus P. So there's my probabilities depending upon what the previous tyre is. Show that so we've got to find, what are we looking for? The third tyre is 0.7. So I know the first tyre is superior. I know the last tyre is superior. The second tyre could be either. So we've got to consider both of those possibilities, all right? So we could have superior, 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 or superior, regular, superior. What are the probabilities? So I guess you could argue that that first probability there is a 1. Okay, probably should have done it in green. Because I know the first tyre is superior, all right? The probability of the next tyre being superior would be equal to P. Let's go back to my highlighter, because that's our branch. And then if we've got a P, the probability of the tyre after that, sorry, if I've got an S, the probability of the next tyre being S again is also P. So the chance of being an SSS is 1 times P times P. The probability of SRS, so again, we could say that the first probability is a 1 because we know it is an S. The second probability, an S to an R, and S to an R is down this path, which is 1 minus P, and then I'm going to go from an R to an S, which is P minus 0.2. So the probability of an SRS is 1 times 1 minus P times P minus 0.2, all in brackets. Now, in reality, we've probably got CAS here from that point, okay? If we don't, we just expand and group because it's not terrible. Expand, P times P is P squared. Expand my quadratic, 1 times P is P. 1 times negative 0.2 is minus 0.2. Negative P times P is minus P squared. Negative P times negative 0.2 is plus 0.2. So straight away, hopefully you can see that my P squareds go, which makes life a lot better. Group my P's together and I get 1.2P. Take my 0.2 across to the right-hand side and I get equal to 0.9. So I end up with P equaling 0.9 on 1.2, multiply top and bottom by 10. That makes it 9 over 12, which is 3/4, which is 0.75, which is what we were looking for, okay? So there's my p-value of 0.75. Part B, on this day, so with P equaling 0.75, Jimmy inspects 3 consecutive tyres, and he knows that the first of the 3 tyres is regular, all right? Find the expected number of these 3 tyres will be superior. So the expected number, E of X, so that's the probability of X times X, so X times P of X. So what's the probability of there being 0 superior, 1 superior, 2 superior, or 3 superior? So we need a probability table. Straight up, we know that the chances of getting 3 superior is 0 because the first one was a regular. All right, so we don't have to consider that. So what are the other options? I've got P could be regular, which we were told, then an SS, regular, then an SR, regular, then an RS, regular, then an RR. Okay, so they're the combinations that I've got left to me. So I've got to work those out. To work that out, let's come over to the right and let's have a look at a probability table. So since I know that P is 0.75, R to an S is P minus 0.2, so 0.75 minus 0.2, which is 0.55. R to R is 1.2 minus P, which will give me a 0.45. So those values there's my probabilities, which I've turned into fractions. Okay, 11 on 20 and 9 on 20. Because I've decided to go through this without a calculator. If you've got a calculator, you would type them in straight away. S to S is equal to, what was S to S equal to? P, which is 0.75, which is 3/4. And so that makes S to R 0.25, which is 1/4. So fill in the combinations. So again, RSS. R is a given. It's green, it's 1. R to S is 11 on 20. S to S is 3 on 4. Multiply them, we get 33 on 80. RSR, R is 1. R to S is 11 on 20. S to R is 1 on 4. So that gives me 11 on 80. RRS is a 1 by 9 on 20 by 11 on 20. And then an RRR is a 1 by 9 on 20 by 4 on 20. Given the last two give me a fraction out of 400, I'll turn the first two into fractions out of 400. If I've done that right and I put them into the probability table, they should all add to 1. And they do. 81 plus 154 is 235, plus 165 is 400. Okay? So there's my probability table. So that's a lot of work just to get to the answer stage, because now I need the expected number. And E of X is simply the probability of 0 times its probability. The 0 times the probability of 0, 1 times the probability of 1, 2 times the probability of 2, 3 times the probability of 3. So fortunately, the first and the last are both 0. So I get a 154 plus a 330 over 400, which is 484. If I divide both by 4, I get a 121 over 100, which is 1.21, which is what we're looking for. All right. So it is a much more straightforward problem if we use our calculator, but not impossible. Okay. It's important that we've got a good fraction knowledge. All right.